can't see is I'm reading off the other screen. I've got like an implementation of this that is kind of a big plate of spaghetti. So the whole goal of what I'm trying to do is to clean things up, make it a little bit easier to work with. And one of the problems I ran into with the contract that I'm building, it's an auction system, and what we're trying to do is basically build it so that only one non-fungible token can be bid on at a time. Once someone has successfully submit a bid, they'll get a ballot, and then they can vote on the other tokens that are in the queue, so that when the current auction expires, the next token that becomes available is the next token that becomes available is the token with the most votes. And then I'm also going to have a fallback so that it's the lowest token ID if all votes are equal, so that I'm hoping that the least exciting token becomes available for auction to just buy some time for more users to come in and bid on the more exciting tokens. I have no idea what the result of this little experiment is going to be, but I just think it's a fun way to experiment with smart contracts and see how many different ways I can try to break the emulator. So with my initial implementation, I'll just bring it over. I basically took the Flow Playground Marketplace and turned it into an auction system, and there's quite a bit here. So I just got lost in a sea of comments and code and decided it would be better to just kind of start from scratch and build it piece by piece and see how to get the little individual parts working without trying to code through this mess and refactor everything. So one of the problems that I ran into is I had a function to start the auction right here, and I set a while loop just to see what would happen if, when the contract was in the wild, if I started this. I guess the hope was that the code would just wait until the block, either the block value updated to run the function in this update block down, or in this update auction method down here, or it would be it would just wait until the auction is no longer active. This would be set to false and it would kill the while loop. But I choked the emulator completely once I run the start auction function, and ended up having some fun with that. So now it's a matter of fixing it up and seeing how to actually make it work. So my game plan with this, it doesn't look like there's going to be like an on-chain solution to manage the state of the auction. Feel free to correct me on that if somebody knows. So my game plan with this will just be to build like the methods to update the auction and then execute them externally, using some scripts and transactions to just monitor the state of the blockchain itself. So that's what we're doing, slowly but surely. I also saw a pretty nifty demo of the Go SDK by Daniel earlier today, so I've been battling the shiny thing syndrome. I really want to get that set up so that I can test things out a lot faster, but I figure I'll just focus on the goal. I'm about a week and a half behind on this. This is my tech assignment from week 3, so let's go. I'm taking a little bit of extra time with these fields because I just want to get them set up in a way that actually makes sense from the get-go. It was pretty unorganized looking from the start, and I think I'm having to wrap my head around building data structures right now and how it's going to work here. I asked a really silly question last week about trying to cram a resource in a struct. Structs are essentially not a place for resources. They can be duplicated, resources can't. So resources are for cool things like tokens, structs are for things like data that can be duplicated and is kind of less secure. So now I have to think about how to manage the data for the auction queue so that I have an easy way to check the start price and vote count for every token that's in queue, and also make sure that people can't vote on the token that's already up for auction, because that would be silly. So fun times. I don't really care about IDs and stuff right now. I just want to make sure I have like the basic data in there that I need to get started with, and then I can start building the transactions from scratch and slowly solving little problems. What I found is I ended up with a whole bunch of code that I don't really think I needed in that first implementation, so that's just gross. That should be... Might as well set it up with settings, right? The whole idea here is that this will be our minimum bid price for the auction, so that'll be like the minimum bid increment. Maybe I should actually call it that. Auction length in blocks, so this will be how many blocks the auction lasts for. Once we have this amount of blocks from the start time for the auction, then that'll end the auction and force it to update from the queue. And then if there are no tokens in the queue, then the auction will end completely. So the owner vault, that's their fungible token vault. So I've got just a demo token, super exciting fungible token example that we'll use here, and that's just like the currency that we're going to use to bid on the tokens. The owner NFT collection, so that's a reference. So this is a reference back to their vault. It's not the actual vault. It's just a way to pass tokens back to their vault, or receive tokens from their vault in this case. I guess, yeah, a vault. We could always explain what that is. So, fungible tokens. Fungible tokens are kind of like coins, right? They're kind of like a Bitcoin per se, where one Bitcoin is equal to any other Bitcoin. So these are a great, currency is a great use case for this, or tokens. So we're going to use that for a currency in this example. Resources, the vault here. So this is the one that I'm talking about. Every account needs to have a vault in order to send and receive demo tokens. So this vault also provides some interfaces for like the developer to, or the owner of the contract or the owner of the vault, to basically provide like a public way for you to interact with their vault, but restrict that so that you can only use certain methods. So For instance, a receiver allows you to publish a reference so that anyone can deposit tokens into your vault, but doesn't allow them to withdraw tokens from your vault. So I just can't pickpocket you for your entire balance. And we've even created a separate interface for balance, so you can opt in to having people know how much is in your account, but people wouldn't be able to actually read the balance of your account without having this a reference to this interface. So this vault essentially is kind of like your manager for your demo tokens in this case, and so we're gonna basically create a reference to that vault. That'll be for the owner's tokens, and that'll be how the tokens for the actual auction eventually end up in the owner's account. The owner's NFT collection, this we're just passing in so that let's say we start an auction and nothing actually happens, nobody bids, the timer just runs out. We're just basically creating a reference similarly to a vault where we call it a collection in this case, where we have somewhere to pass the owner's tokens back. So once they leave the auction, they go back into their just normal collection. They're no longer available to be bid on or voted on for the auction. And then the bid vault is actually just a new vault that we're going to pass. Yeah, we're going to pass it in when we create the actual auction, and that'll just control the actual tokens within this auction contract itself. So it'll give the contract a vault to send and receive tokens from. Before I get too far ahead of ourselves there and forget to explain what's actually going on. Rocks, while we're looking at these things, pretty boring. It's a really basic, I just wanted to call it something other than non-fungible token. So I actually do have an implementation of a non-fungible token called rocks with metadata, and it like just basically depending on what the current block is will mint a certain type of rock. Once I get the actual auction contract up and running, we'll get that rock contract in here, and it'll be something different. You'll be able to see differences between the actual non-fungible tokens, which should be super cool, at least for me. So anyway, I'm probably gonna go back into my quiet place for a little bit while I try to figure out how to build this puppy. Mistake and you want to do the exact same thing the next time, especially when you're on camera. It's good times. That's weird. Oh yeah, no, okay. So I was hanging up on myself there. I forgot that I was just passing a reference and not the actual token or the actual resource itself. So I was trying to use this fancy little move operator and pass something that wasn't a resource into my local variable, and it was saying no. And that's part of why I love Cadence, is it teaches you how to protect yourself from yourself. But in this case, we do want the move operator. It's been part of the fun of learning it though, is like the just the new little things that you deal with. So this is move. This is just to kind of give you a visual indication that you're actually moving a resource from one place to another, which is very different than setting a value to the value of something else. So this no longer exists in its former location after you've moved it here, which seems kind of duh, but it's actually a big deal. So learning that, learning where to put these little @ signs, those belong on the front of resources when you're declaring a type. But every now and then I'll try to cram it there. It doesn't belong there. It's just good times. Overall, though, it's been a really enjoyable experience learning this language. I think we'll probably want to track the start block. And that will definitely be changing. Oh yeah, one other thing that trips me up. I don't really code a lot of JavaScript, but I definitely learned JavaScript before Cadence, and so these are kind of backwards in Cadence land. Like let in JavaScript is a variable that will change. But in this case, let actually works like const in JavaScript, where it's a constant, so you can't change let. You'll get a screaming error if you try to do it. Var is the keyword that you want to use if your variable is going to change over the course of the program. Yeah. So that'll just track the actual block that the auction starts on, which is very important when we're trying to do a calculation to figure out when this thing is going to end and to queue up our next token. We're just gonna set that to 0 to start, so it has a value and it's happy, but we're gonna update that when we actually start the auction manually, because we want it to be accurate. And when we create one of these auction collections, there will be a method that is start auction still, so that the owner of the auction has time to queue up all the tokens that they want in place and make sure everything's right. It would be a little aggressive to start an auction right away, I think. I don't know. Open to suggestions. Sorry, my screen keeps cutting out like that. It's just a fancy Windows feature, I think. So my previous implementation, I had last checked block as a local variable. I don't think we really need it. I think we'll just be able to run a script that monitors the block height, and off-chain just executes a transaction that updates the auction when it's time to end the current one and bump the next one up in the queue. Okay. So all the fields I'm going to want to set up for now, so let's just clean that up for the time being. Yeah, so just the basics. Got the auction queue. So this will be like the dictionary, so it's going to hold the ID as well as the token. An easy way to kind of just get a list of what's in the queue. I am going to want to figure out a way to add some metadata to this and manage that better, but I'm not quite sure how to do that yet because I'm just a wee web designer, or not even a designer. I'm just a wee WordPress guy. So I'll figure that out in a little bit. But the current auction item, I used an array. Again, I'm not sure exactly how to instantiate just an empty variable that's supposed to have a resource in it. So ideally this would just have a resource that sits in it and it holds it separately from the auction queue, but noob's gonna noob, so I'm noobing. And then yeah, these are our settings. So minimum bid increment, so that's just the incremental value that we'll be using to bid. Just gives us a setting and a way to say, hey, that's not enough, you need to bid more. Auction length in blocks, I've gone over it, but hey, why not go over it again? It's the length of our auction in the blocks, so we can actually set it. I think we're gonna like test it at a minute or something, or like 60 blocks or 30 blocks. I'm pretty sure the block time is supposed to be roughly a second, which is super fast. Auction start block, so that's for when we initiate, like when we execute the start auction method, we're going to record the block time, or the block height then, and that will just give us a reference to when the auction actually started so that we know when to end it. And then here's just our references to our owner's token vault and our bid vault to manage the coins for the actual auction. So we should probably give people a way to, or give the auction owner a way to add their tokens to queue. I'm so cheating. I'm looking at my old code, so I apologize in advance if I take super long time to code everything, but I wrote it all once, so I might as well make it somewhat similar to the first go. I do find when I'm learning something though, I do like to type things out like over and over again. Like, even though it takes time, it's good to get the reps in because you do get a little bit more comfortable with how things work. So we're gonna use the actual token. Non-ping. Fixed point integer. So let's talk about what we're doing here. Add a token to the auction queue and 6 restart. So we're going to store the token ID. Let's just get in the habit of naming things well. So we're going to want a way of recording the start price, which is already getting me into my data structure discovery fun times. So I'm just going to comment that step quickly. Start price. What did I do? So I'd want to store the start price. I want to set the vote count, the code count. We'll give it 0 votes. Makes sense. And then we'd want to add the token to the auction queue. So we do this fancy. This basically pops out any old token that would have been at this ID or at this key in the queue. And replaces it with the current token. So in our case, I'm pretty sure we'd never actually have an old token because our code is minting tokens with new IDs every time, but this is just resource-oriented paradigm. We want to make sure that we're just getting rid of the old resource before we, well, you'll see, because the next line is destroy the old token. And that basically helps us, like if I don't do this, we should see, okay, we're not seeing it, but at some point we'd see an error saying loss of resource. Basically we have a token sitting in cyberspace that we aren't doing anything with. We're not storing it anywhere. It's just basically going to get lost once the program stops executing, and that's a really nice feature of Cadence and how Flow has been designed. The like safety and security around these tokens is next level. Like for a developer like me, like just going back to kind of what brought me here was I got really excited about Ethereum when I kind of caught on, like CryptoKitties piqued my interest into non-fungible tokens and what those could actually do. Like I'm a big time Magic the Gathering collector, not such a good player, but I really loved, like, you know, the collecting aspect. I just thought the cards were really cool. Like from a super young age I was all over the artwork, and I ended up just kind of like, I moved around a lot as a kid, and what kind of sucked about that is like my friends would end up being like 45 minutes to an hour and a half away, and we could never play like Magic anymore. So I'd have all these buddies that like we'd play for a few years and like, you know, get really into it together, and then all of a sudden we'd be separated. And you know, when you're 11 or 12 years old, 45 minutes away is, you know, you might as well live in another continent. So we could never really play online, and like Arena's sweet. Like I like it, and it's cool that it came out, and I like having like an online way to play it with my friends, but they're still not my cards, right? Like it's not correlated to my deck. So when Gods Unchained came out, that was a super cool thing to me. Like it's not Magic, but it's close enough for me to understand, okay, like this is what these can do. Like this is the kind of the gap that we're bridging with non-fungible tokens, and it's really just the beginning, right? So when I got into Ethereum, like as in just trying to play with the code and trying to wrap my head around Solidity, like I'm clearly not like a, you know, 10x developer. So I figured out right away, like this is gonna end up costing people a lot of money. If not me, I'm gonna end up costing my users, you know, an arm and a leg, because I'm gonna end up writing something wrong. I'm not gonna do security as well as I probably should. So just because I don't know what I don't know. So with Flow, what I'm finding right off the bat in Cadence is like this whole resource-oriented paradigm of having these things be private and inherently secure, and having to, you know, either opt in or really creatively back yourself into a corner is really comforting for me, having, you know, very little experience with this type of development. So
I found that like I can get out of my comfort zone a lot faster with this and with resources, and I'm just really enjoying the fact that the editor screams at me when I do something stupid, or when I do something I'm not supposed to, because it's it helps, it teaches you quite a bit. When you spend a full day coding it, you don't feel lost, or like you're swimming to shore from the middle of the ocean. So props to you over there at the Flow team. So we're going to destroy that old token. That makes sure that if anything was in there, that we're just going to kill it. It's going to be gone. We've handled it, and it's not going to be sitting out in the nether regions of the contract until the program finishes executing. Sorry for the long-winded explanation. It's just clutch. I'm probably going to stop on that topic a few more times just to try to nail it in, because I don't think I did it justice. Yeah. So storing like this metadata for the auction queue is going to be a pretty fun little problem to solve. I'm going to go take a breather. I will be back.
And we're back. Alright, so I'm thinking I might just tackle this beast by doing it the way that I did before, just to get her working, and then ask the powers that be on the flow team what the best way to do it would actually be. So, the it that I'm referring to would be like the metadata for this auction queue. So, how I did it before was just setting up a dictionary. So auction key prices, and this one would just be the ID of the token and the fixed 69, nice. And then, so yeah, the ID and the price, and then the auction queue votes would be token ID and yeah, I guess it would be an unsigned int, because we definitely don't have -1 votes, so that'd be a really unpopular token. So that's how I set it up. What I really want to do is like kind of build, and this is where I was thinking like a struct, and I could be way off base, but I wanted to have basically like one object that I could query by ID and then access either the price or the votes value and return, or sorry, the price or the votes label and return a value for that particular token. I have no idea how to do that yet, so that's one of the adventures that we get to go on sometime this week. So for now, I'll just set those up as empty dictionaries. Oops, how's that? Resources either. So I'll just set those. Stop to turn the camera on and I forget how to code. Oh yeah, so that gives us enough to play with these. So now we can I created a method to change the start price on these before, which I should probably do again. I'm still also wrapping my head around access control, so I've been just kind of declaring them public for, you know, testing purposes. What I might end up doing when I'm actually testing this out is to restrict them all completely and then just slowly scale it back to see how everything works. That way, when I'm trying to run code, I'll just get errors instead of, you know, pushing potentially unsafe methods out into the wild. Because I really just don't want to cost people any money or concern with this stuff. So it'll take a token ID and a new price, and we will look for the value in the auction prices dictionary. And we will update it to the new price. So if one doesn't exist, then we will set it to the new price instead.
I always get so hung up on comments trying to be super specific. One of those like super hard on yourself coders that takes longer to learn things because I'm spending too much time worrying about things that they matter. But they matter more towards the end of the project than right now. Okay, so kind of reading from one screen and coding from another one, so I accidentally used the old ID value that I named poorly. And we'll use our new price, which will be our start price. So just basically, in the spirit of keeping things clean, we'll just create that method because we're going to want to be able to use it again later. If say I've added a token to the auction queue, but I want to change that price after the fact before it goes into the auction. Yeah, just thinking maybe I should specify that in the comment, but there's no real good reason to do that because you won't be able to modify that by the time the token gets into the auction. It will be out of the queue. Alright, and I can just set this one manually. Auction queue votes, token ID. And that one equals an unsigned links of 0. We don't need a 64-bit there, but let me just do it because we want this contract to take off and we want to have just billions of tokens and billions of bidders. So we're optimistic people. The future is bright, folks. Okay. I mean, technically, we could just create a method to create a new auction collection and start testing this guy out. So maybe that's what we should do. This could give us something to see. I guess I should also create a destroy method. So because the auction collection resource contains other resources, we need to tell it what to do when the auction collection is destroyed. Again, it comes back to this concept right here with resources. We can't just lose resources. We need to intentionally do something with them. So we need to either store them somewhere or we need to destroy them. So with this destroy method, when we destroy the auction collection resource itself, we need to also destroy, at least in this case, the auction queue, the current auction item array, self bid vault, all the resources that this contains. And again, like, this will not deploy, like you won't be able to execute your code if there's an error like that sitting here when it's actually time to go. So you don't have to know that ahead of time, which is really nice. Like, again, I'll keep coming back to it. It's one of my favorite features of the language, and like this whole strongly typed system, everything is screaming at you if you're doing it wrong. It can get really frustrating when you don't have like a really strong software development and like structural background. Like, that's my problem, is that I don't have like a software design background, so I'm learning quite a bit by the errors and kind of opinionated nature of Cadence. And I think that'll be really refreshing for a lot of people that are coming from like, say, like WordPress or JavaScript, like really light JavaScript backgrounds, and not so much like the server side, system side development background. So in this case, we're just going to destroy the auction queue, the current auction item, destroy the bid vault. I think it's important to also note that like you don't have to do that. Like in this case, it's pretty like it's destructive. What's going to happen is, say I've put 10 of my tokens in this auction queue and I destroy the auction collection. Well, I'd probably prefer to have my tokens come back into my collection, and you can totally do that here too. So you can actually run like a function that will loop through all of the tokens in the auction queue and deposit them back into your NFT collection. So because I'm just kind of going quick and dirty, and it would, you know, I don't have that code in the back pocket, I'll probably just write it this way for now. But the goal with all of these little examples is to kind of flesh them out to be like a real world example, so we'll eventually get to that. I just thought it might be important to kind of note that you don't have to destroy these in that method. And in this case we probably shouldn't, so I'll even to do that. So we'll pop the NFTs back into the owner's collection. We'll also deposit the bid vault tokens back into the bidder's vault, so the person doesn't lose their tokens that they submitted to the auction. So that's kind of one of the flaws of this contract. On my side is the actual token, like the NFT side of things, is non-custodial, so your NFTs never actually leave your flow account. They sit in a different resource or in a different storage area, and basically people can just see that what you have up for auction is separate from your token collection. So it gives them the ability to bid on your tokens, but you still own them. They don't have to go to like a third-party custodial source that holds on to them for the course of the auction. The downside though is the bid, like the tokens that people bid with, will sit in a vault that lives on the contract itself. So I'm sure I could probably code this in a more composable way that, like, or in a non-custodial way that the tokens get also stored in like a vid on, like, or in a separate vault in the actual bidder's account, which would be the better way to do things, right? Because then nobody actually loses possession of their fungible or non-fungible tokens until the actual auction is settled. So tons of opportunity to improve the contract, but again, it's kind of this is a tech assignment. This was never supposed to be like a 3-week project, but it's super close to the team project that I'm working on for Open World Builders, and is kind of fun, to be honest. Like, it's overwhelming, but it's a lot of fun, and I'm learning quite a bit from it. So yeah, we're gonna rock it. We're gonna make it work, and then I'll be able to use like 80% of what we build here for the team project. So it's all for a good cause. Plus, I just kind of want to see this thing working. Like, it'd be really cool to see if this is actually fun. So we're going to create a method on the contract that allows us to create a new auction collection, and that'll allow us to kind of start testing things and see cool things happen. Okay. So this is the fun stuff. This is where we pass all those sweet values in. This is also where we'll actually create our vault. Or no, it's not. We'll do that in the transaction. Sorry. just where we are creating or passing in our values to our auction collection to actually create it and pass it back to our user. So the any resource thing here is part of the magic of composable contracts. So instead of using the like rocks specific contract language in here, I'm using the demo token specific language. We're setting this up so that you could essentially use any fungible token or any non-fungible token as long as it's got the standard interfaces here. So it's pretty cool. Like you can mix and match like rocks and demo tokens with whatever you want, as long as they follow like the token standards from the onflow repo, which is really important. Like I think one of the big, like the coolest parts of like the non-fungible tokens and this space in general, like this whole creative collaborative space, is the fact that we're all kind of building on top of each other's work. So like we're all collaborating, we're all extending each other's work. So we want to build things in a way that, you know, anyone can leverage your code, or you know, like this auction could really easily be included in say Flow's NBA Top Shot marketplace. If it was a fun way to, you know, buy and bid on tokens, they could really easily import this and build their own front end on top of it, and it would just use this code and it would work kind of out of the box because it's working with the any resource like an interface from the token standards themselves and not the custom contracts that I've created. So there's still a few things that we're kind of discovering that are making like the composable nature of things a little bit difficult, but I think it's really cool, and it's definitely on its way to being something pretty amazing. So I'm not sure how much I can say about the upcoming cool stuff in that world, especially around like CryptoKitties and stuff. So I'll wrap it up there, but build your contracts to be composable, folks. It's definitely worth your while. I think that's probably like the most fun thing about this space is like, at least for me, I came from kind of like a closed door situation where you couldn't really talk about like your ideas, right? Like you're always worried about somebody taking your idea and running with it. Like before blockchain came out, we were in Web 2. We'd been in Web 2 for so long that like the space had become really saturated, and it was hard to come up with a novel idea. Like I had a heck of a time trying to come up with anything new, and you know, so in this new space, it's just kind of created such an open landscape. Like there's business models that are being generated every day because there's just new possibilities with these tokens. Lane on the Flow team kind of nailed it when she said like we're merging the best parts of physical assets with the best parts of digital assets, which just allows us to do things that we've never been able to do before. So it's an exciting space, and that's where that whole composability thing like really kicks in. Like if developers focus on building little pieces of something bigger, like a small piece of functionality that's just, you know, really well done and completely abstract, then everybody else can leverage that piece and build something, like build the next step on top of that, right? And you're really starting to see it. Like we had a really good talk about like the DeFi space earlier this week, and I didn't even realize, like I have some DAI, like it was talking about like the Maker ecosystem, but like I didn't realize how many layers were actually built on top of Maker, and just like it's a perfect example of that, where, you know, a developer has a great idea, then 4 more developers see that idea and kind of take it their own way, and that just kind of exponentially keeps growing, and that's just the most exciting thing about this space. So I'll stop beating that drum now, but yeah, really cool. love the whole composable nature thing, and I love the collaboration. I think we're going to see some really cool stuff between like developers and like designers and artists in general. We're already starting to see it. So I was actually talking about like just tokenizing artwork with a tattoo artist in my family, and she lit up when she heard about like the fact that you can kind of do this. You can build these tokens in a way that you know, that you don't have to really sell them for millions of dollars. You can kind of almost get like a royalty every time it changes hands, so you can get like that percentage every time it changes hands in a marketplace or whatever. It's just a cool new way of building things that people are still kind of becoming aware of. Hopefully that's making sense. I'm kind of talking and coding and not doing a great job of either, so. The other thing is you'll get to see all these red warning lines go away once I start deploying contracts, which will be refreshing. Yes, it is for me. Okay. What else are we passing? Oh yeah, there's settings. Minimum bid and auction length. Feels like a lot, but it just feels like it makes more sense to be able to set this on like a per auction basis. So we will make this. Call it 10 tokens to make things nice and obvious. We're gonna launch our accounts with like 200 each or something like that. Maybe we'll go 5. 5 tokens per bid, that just gives us a little bit more room to play. Auction length in blocks, we'll do... we'll just do 30 to start. We'll just give it 30 blocks. So every time we run a transaction, it's going to advance a block because we're using the emulator. So, and that'll just give us... yeah, that'll just give us the opportunity to make a few bids and votes and cast a few votes for every token without having to wait like a ridiculously long time or having to run out of tokens to use for testing. We can always change those values, but it's nice to not have to. The arguments also have to be in, or the params also have to be in the right order, I think. That's isn't it? Oh gosh. So good load at the bottom. Much happier. So yeah, you can see how it yells at you. Like, I love that. I thought I wouldn't, but but I really love it. And I mean, it honestly stops so much, you know, banging the head against the wall and requesting help from the team. So like, I do find if you spend 5 minutes just looking at it, you will answer your questions. Definitely do reach out if you get stuck, but It's pretty fun to code in. It's pretty good to learn. So that's pretty much all of that. We're gonna add that. So what this does, like, interfaces are sweet. Hopefully this explains them really well, but the way that I kind of see them is your resource is going to have fields and methods, but you're not going to want like everybody to have access to all of those fields and methods. So when you've built your resource out, you can basically put like a shield over top of it that only gives people access to certain methods. I kind of explained it to my electrician buddy as like a circuit board, right? Or like a circuit breaker, where there's a lot more going on underneath that panel. But like for the average homeowner, you don't want them to touch that stuff because it can either hurt them or it can hurt the house, right? So what you're doing is you're putting an interface over top of that that only allows them to touch like certain the breakers themselves, and that just restricts, you know, what they're able to do for everyone's best interest. So you can do the same thing with interfaces. You can add, you know, just the methods that you want the public to be able to use in the public interface. You can add like an admin interface and just put like more admin related methods, say like minting tokens or something like that. And then you can pass out your references to those interfaces themselves. And that's essentially what we're doing here. Is when we create this auction public, we're going to allow this add token to auction queue. We don't really need it, to be honest. We're gonna probably remove that because that's actually, the more I explain that, the dumber that is. But because it's only our auction owner, the person who actually created this auction, that we want to be able to add tokens to it, at least for this example. So we wouldn't really need to make that a public method. When we do get to the voting, like the cast a vote, then we want to put that in here so that anyone that has access, that has a ballot, can use the reference to this interface to call that cast vote method and cast a vote on the resource itself. Sorry, my brain is not very good at English today. Yeah, so that was a useless demonstration, but I think it was like hopefully that was a decent enough explanation of how this works and why this actually isn't necessary. Like, so if I own this contract, or if I own this resource, I actually have access to everything on it. I don't need to pass a reference to anything because I can just reach into my account and use it. But if I am somebody else who doesn't own this resource and doesn't have it stored in my account, I'm going to want to use the interface to interface with the resource and call whatever method that I need access to. Yeah, so right now it doesn't actually need anything because I'm just going to access it from the owner's account and test adding my tokens to the auction queue. So the poopy part is somehow I lost like all of my previous scripts and transactions that I wrote to test this stuff out. So I have to like redo everything, and that'll be fun. But oh well, it's better for you. Better for you because you get to watch me struggle a little bit. A lot of this should be pretty simple. So we'll just get the emulator started up and you can see what's going on there. So we're using just post in chat. distracted. So we're using the CLI, the Flow CLI. Just gonna post it in chat and then I'll open it on the screen. Everything has to be difficult because it's live. So you can get the Flow CLI from the link I posted in chat. I'm such a noob to streaming that I have no idea if you're actually going to be able to see this if you're watching it later, but it's there and you can do a quick little Google. It looks like this. Oops, it doesn't look like that. Look at that. It looks like this. And so the CLI is just like it's an emulator, so it emulates like kind of the majority of the blockchain experience locally on your machine so that you can use it for testing. So it's available for Linux, Mac, and Windows. I kind of just use it, like I'm using Windows right now, but I'm using Subsystem, so I'm technically using Linux. I've never really experienced the Windows side of things, but you can definitely reach out in the Flow Discord if you're having any issues with it. So you just want to install the CLI, and then once you've got that installed, you can from the command line just run flow cadence install VS Code extension, and it will install it into VS Code. I do recommend, like, this is kind of my favorite environment, like the VS Code environment for working with it. You do get the most up-to-date features, it seems like, so there is a pretty rapid development curve on Flow. So I've noticed, like, we started the Open World Builders program 4 weeks ago, just over 4 weeks ago. I believe we were on like 0.4.1 or something like that of the Flow emulator, Flow CLI, and the last time I checked, I think we were at 0.7. So it moves fast. So I just like I do like having access to like the more up-to-date features. There definitely are some breaking changes, so you have to be aware of that. Max from the Flow community team, he's put together a couple of great live streams. He's at Block Trainer on YouTube. I would definitely check his streams out because he's using like a Docker approach to the Flow CLI, which can really help keep your dependencies a little bit more in line. Like, we had a few issues trying to demo some front end stuff where like the dependencies are a little bit out of date, and so like the demos were kind of just exploding in our faces. So it's the way Max got around with that was just using Docker, and that way he can kind of make sure that he's got the right at least like a consistent version of the CLI, and that way he knows what dependencies kind of fit with that and work with that, so you can keep your environment somewhat stable for development. So definitely recommend that. Definitely recommend checking out his videos if you get a chance to do it. And he does some pretty fun stuff. Like, I'm going to be spending a lot of time in the contracts for a little while, where Max is over in the JavaScript side of things, and he's actually showing like more interactive demos where you've got like a wallet in browser and you're actually able to see things going on the front end. So I think for some people, especially more front end developers, that's going to be a little bit more exciting. So yeah, there's a third plug for Max. Go check his videos out at Block Trainer. Okay, so once you've got your CLI installed, you can just interact with it through VS Code's action panel, I guess you'd call that. So when you run it, it's going to fire up the emulator, it'll fire up the ports for communication, and then it'll create 2 default accounts. Every once in a while it seems to have issues creating those default accounts. So I find if it doesn't do it fairly quickly, I'll just stop and restart. The old turn it off, turn it on again. Oh, and because we're live, it's not going to work at all. So if that's happening, I like to stop it, restart the language server, and then try it again. Oh, there we go. So we got 2 new accounts created. We're gonna create 2 more because I need 4 accounts for this demo. Oops. And then I'll go a little slower. I apologize. I'm busting through it like I'm running a race here. So I've created 2 new accounts. I should have 4. So when I go to switch account here, it'll show me the 4 accounts I have. This top account is the service account. Just a heads up, there's a lot of code installed in this service account already. So if you try to deploy a contract to this service account, it is going, well, it's probably going to fail. I don't want to say that it's going to. Just don't do it. It's not what you're supposed to do. It's wrong. You're better than that. So what I'm doing for this contract is I'm actually going to jump down to account 4. I'm going to deploy the non-fungible token contract standard, which is a mouthful. So what this actually is, it's written by the Flow team, and this is kind of like the blueprint interface for like the requirements for all non-fungible tokens. So like this provides us with a way to make sure that we're building tokens that other people can interact with and other people can also build around as well. I have run into a couple issues that we're kind of chatting about on the Flow side, where sorry, that was like horribly articulated. We're chatting about in like the Flow Discord, and just kind of I'm trying to push the issue a little bit with people, because I'm trying to build a rental marketplace. And we're finding that we're just basically running into issues where like this interface is super helpful, but it's also limiting what we're able to do with our custom contracts. And we're trying to, like, I'd love to see this built in a way that we can add all of our methods to this NFT interface down here, and like everybody that's trying to interact with these tokens and build on top of them would know that like there's like a public interface that all of the token specific methods would live in. So that's something that, like, you know, I'm continually kind of chirping about in the forum and stuff, and hopefully we'll get there. Hopefully that was clear. I shouldn't have even gone there, but oh well. So anyway, we're gonna deploy this token standard. What this is just a blueprint, right, for a non-fungible token. Just to reiterate what I horribly said there before. So this kind of gives us the foundation that I'm using to build this rocks token on. So once we have that deployed, it just makes life easier for me to go ahead and deploy all these other tokens. So the reason I'm cramming it in account 4 is because I think the intention is for these token standards to already live on the chain, and you should be able to just import them from an existing address. That's how the fungible token standard works. But it seems like the non-fungible token standard might still be in development or something. So that's now deployed. We can see we deployed it to account 4. And we're gonna deploy our demo token to account 1. So this always trips me up, but make sure that you have the proper account selected, or you're just gonna end up with an error because you can't deploy code to an account with code already deployed into it. So you can only have 1 contract per account right now. I think that's supposed to change. Did I just screw up? I think I screwed up. I did. That's what talking does. Okay, so I'm just gonna stop and restart my emulator because I deployed things to the wrong places. So let's just scrap everything that I said, and I'm just gonna show you what I'm doing instead of explaining first, and then I'll explain after I do it. Because reasons. Okay. Created my new accounts, switching to account 4, deploying my non-fungible token standard so it exists. Account 1. This is intended to be the that didn't even mess up last time. The demo token contract. So actually was right, but hey, I did it just for you. Count 2, this is where we deploy our custom fungible token. So this is where you can see we're grabbing our non-fungible token from account 4. See? Account 4. And I've also kind of listed them out here because it's just easier to grab them from a comment when I'm working. But this pulls in that interface that we can then use for our token when we're building it. And as we're building it, it'll give us those helpful little errors when, you know, we're missing a method that we need or something isn't quite right. And that's about as far as I'll go into that right now, just for the sake of keeping things simple. And finally, we will deploy. No, we won't. Before we deploy it, just going to make a quick method that will be able to use to just check the auction queue. So this will just return the whole dictionary with the token IDs and ugh, no, we don't want that, do we? Yeah, no, we just want the keys. We just want to know which tokens are in the auction queue. So we're just going to return an array with unsigned ints. Yeah, like ideally we'd return IDs and prices. Yeah, you know what? That's what we'll do. We'll return auction queue, get auction queue prices. So that'll give us a way to see what which tokens we have in our queue and what the prices, what the starting price is for each token. Return self auction queue prices. And we'll pop that up in our interface because that is a decent use of the public function. Get rid of those. There. Now everything's useful-ish. It's telling me we don't have a member of ID. We don't. It's lowercase. So now that error goes away. So that's helpful, right? Like we're importing our contracts. They've been deployed now, so we actually have errors showing up based on the context of what's in here, which is really the way you should be doing it. I think this is receiver. Yeah, so those are supposed to be the receiver interface where I was actually trying to use a vault, which isn't even an interface. So that's yet another helpful way of screaming at me to let me know that something is not right. And then yeah, so this should be using collection public. So again, it's just telling me, hey, you are doing awkward things. Reassess your life. Cool. Alright, so our whole contract is ready to be deployed at this point. I think what I'll do, gonna create some events. So new auction, collection created. Yeah, let me just double check what I had before because I am not wanting to create a bunch of weird events that I don't actually need. But these are helpful. Like, so events will fire off. You can emit them on the contract side when you execute code, and then on the front end of the site, you'll be able to kind of like hook in or listen for those events and then execute functionality based on what happens at a given time. So it's a really good way of tracking what's going on the contract side. Yeah, so kind of want like a new auction collection created. I don't know if I really need to pass anything to that. I don't think I have anything to pass to it. Yeah, maybe like the minimum bid. So minimum bid increment. That'll be the fix, and we'll do the lengthen blocks. Come on. So we'll have that. We'll have an event for token being added to auction queue. We'll have token ID. We'll have start price. We will have token start price. Updated. Pretty much all we have right now. Admin, change one, medium for that. So. Okay, cool. So I'm going to emit. Token added to auction queue here. Token ID will be token ID. And start price will be start price. Love it when a plan comes together. Emit token start price updated here. Token ID. What am I doing there? That's the wrong thingamajig. There you go. Trying to pass a type in when I should be passing the value. And then down here. New auction collection created. I'll use the same values. I guess we'll set them up here. Use them up there. We'll set them up there and we'll use them down here. It goes dry. Okay, so that'll also do something on the console side when we actually deploy, or when we create a new auction collection. Like, these events will show up down here, so it'll just kind of give us a little bit of extra confidence that what we want is happening. But from what I can tell so far, like, the actual information that you get in the console isn't the most helpful. Oh well though. So I'm pretty confident that we can deploy. Just double checking that we're deploying to the intended account. So, like, the tricky thing about this is, like, especially when you're doing these, like, local demos for yourself, you want to make sure that, like, your imports are right. So that's why I put a little bit of extra help in here, just to make sure that I have, you know, a reference to where I've actually deployed things or where I intend to deploy things. It's really easy to get yourself tripped up, and like I said, like, leave comments for yourself at the top of pretty much every file that you're building for transactions. You want to know who's the signer, who's the intended signer for the transaction, and then as well as where you have things deployed, so it's just easier to grab them from. I haven't found a fast way in the emulator to get your current address, so save yourself. You deploy that, right? So it's nice you can redeploy, so there we go. We good. We're deployed. We can officially test our code out and start trying to run some transactions. Just resave everything. I'm sure it just added a line or changed something unnecessary, but hey, let's do it. I had rocks deployed, but you never know. Okay, guess I didn't. So this should just work. What we're doing for this first transaction is we're just setting up account 1 for the auction. By publishing a vault reference and creating an empty NFT collection. So account 1 is where we have our demo token stored. So we just need to publish a reference to our vault. We don't need to create a new vault. I believe we created a vault when we deployed our demo token contract, because that makes sense. The non-fungible token collection we don't actually have in that contract, so we need to import that from where it is stored in account 2, and then using the namespace for the rocks contract, we're going to call the create empty collection method on it and store it in a rock collection in our account storage on account 1. Once it's stored there, we can create a public collection, a public reference to our collection public interface and store that in our public domain. And this is what say account 2 would reach out to in order to deposit NFTs into this, or in this case our contract is going to reach out to this rock collection reference and deposit their non-fungible tokens. So this is good. We need this as is. This will help us with our little demo here. We don't need to change anything. Everything's good. We can execute this with account 1. So we're going to sign this transaction with account 1. And if all goes well, we should see some happy green messages down there. Well, blue. There's really nothing changing hands, so there are no events, but created our vault reference, created a new empty collection, and published a reference. So account 1 is officially set up and ready to party. Okay, so the comment is wrong. Okay, so this uses, we're signing it with account 2. We are using the rocks contract that account 2 owns. It's stored in account 2's storage. And what we're going to do is we're actually going to get the minter, and we're going to mint NFTs, or an NFT for account number 1. So this one, I'm actually going to update and just loop through an array of 10 and just create 10 NFTs for the account 1, because we want to auction with more than one NFT. But otherwise, this transaction is going to create an empty demo token vault in account 2's storage so that it can send and receive demo tokens for the auction. So yeah, create the empty vault, store it. We're going to save it in storage, and then we create 2 references here. So we're creating 1 reference for the receiver, 1 reference for the balance. I'm pretty sure I'd updated this in like the version that I had written since, but we've lost those changes, so that's all good. I'll figure out what I did and make it better. And then down here we are borrowing the minter, and then when we execute this transaction, so there's a prepare block here. This is where we set everything up and get it ready. Some transactions won't actually even include an execute block. They'll just be like linking and setting up their account for future transactions. In this case, we're actually going to execute some code. So we're going to get the public account object for account 1, which is going to allow us to look for the capabilities stored at public rock collection. This is called optional unwrapping. So we need to force unwrap here, which basically means that if we can't find this reference, then just delete. Or we can't find the capability, then just revert the transaction. It's borked. We can't do it. So it's atomic, meaning like it either all happens or none of it happens. So this is just a quick way to say, hey, this isn't working. Just abort. Let's stop this transaction from happening. If it can find the capability, that's great. We're going to borrow a reference from it to the collection public interface. And if it can't find that, if it can't borrow that reference, it'll panic and let us know that, hey, we weren't able to do that. So there's a couple of quick checks here. Both of these values could potentially return nil, and we're just handling them in a couple of different ways. What you'll probably see, another shout out to Max, I like the way he splits these up, so we'll probably end up doing receiver cap, and then let receiver ref equal receiver cap, and then all this good stuff down here. So this just cleans it up a little bit and makes it a little bit more clear what's going on. I like that a little bit better. It's just a little bit more clear, and that way we're not running through like 2 different steps to make things happen. I don't really think it makes much of a difference to your code at the end of the day. It's just I like the way he organizes it, and it just makes those steps a little bit more clear. So another big shout out for Max, dropping the love. Block Trainer, go check it out. Change your life for the better. Okay, cool. So I mean, this actually works. So we're just gonna leave it this way. It's cleaner. Clean up this comment because it doesn't make that much sense now. Get the public capability. I think like another important note like on just this space in general is like, since we're kind of changing the game and flipping things on their head, like de-obfuscating your code as much as possible is like the most helpful thing you can do for the community, right? So like don't go overboard on comments, like be concise, but like do try to clean your code up in a way that people are going to be able to read and learn from it, because that's kind of the ethos here now, is like we're all trying to help each other out, we're all trying to make each other better developers. So if you can write your code in a way and comment things in a way that help people understand what's going on, they're going to be able to give you better feedback, and you know, if they're say more of a novice developer, they're going to have a better idea of what you're trying to achieve. So just a little thought there. Reference to the collection public. Alright, so that cleans things up and tells you what's going on. We can execute this. Actually, I want to loop. I'm just gonna call it 10. So we're just gonna say let's do this 10 times. So loop. Do a little counter approach, I guess, the best way to do it. So, just pop this whole thing in here, because sure, why not log every time you create a token, but we should also see an event every time that a token is created. Yeah, you know what, I'm just gonna move this down so that we don't fill up our console with logs. That's pretty self-explanatory. There we haven't named our stuff. I don't know. Call this rent a token. I don't know. There we go. I have questions, so I'll just answer the question. Enjoy. Okay, cool. So this should, when I run it, I'm gonna run it from account 2. And when we look down here, we should see some helpful happy. Oh yeah, I didn't even commit my counter. Beauty. Beauty. Let's listen to the fans heat up. Oh yeah. Alright. Well, let's restart everything. Live coding for the win. Be happy. Hey, cool, I didn't have to restart the language server, that's nice. Okay, so create my 2 new accounts. Switch into number 4. So this is the process that, like, I absolutely despise. And I think most would join me on that. So it'll be nice to automate this away with some Go. But I want to walk before I run, and I think it's best to focus on Cadence while I'm still learning. Okay. Everybody's deployed, everybody is happy, and we'll go to camp 1, and we'll run our setup script. Publish our vault reference and create an NFT collection. Switch to account 2. update our counter variable before we do the same darn thing again. Counter equals counter. I don't think there is a plus plus. I've never. Let's try. No. So we can't do it that way. We just actually have to assign it a value plus itself. So now we will increment properly and we will achieve the end of our while loop and not break the blockchain like BVs. Cool, so double check in, we're in account 2. We're gonna fire this off and we should see finally our happy little messages saying that we have minted some tokens. Pew! So we've created a vault, published the references to that vault. We've created 10 NFTs for account 1. We've minted and deposited them, which you can see through this sweet little event. And that's something that you'll be able to look at on the front end, and it'll actually be able to tell you give you some insight into what's going on. So I feel confident now that our account number 1 owns 10 NFTs. And you know, it's just a great feeling. So I'm gonna have a breather here quickly, and then what we're gonna do is finish our setup scripts for transactions for accounts 3 and 4, and then we will update our minting transactions so that we can give accounts 1 to 4 the required amount of tokens for the auction, which I'm just doing because it's a part of the process, but I mean we don't really need it for this test. And then once we have that done, I will actually put our listings transaction together, and we will create an auction collection with those 10 NFTs in it, and we will be able to run a script that will show us our collection. That'll probably be where we wrap up today, but hey, not bad for a completely off the cuff setup stream, right? Anyway, toodles, I'll be right back.
technical difficulties there, so I'm just letting people know. Okay. So we are going to carry on with the setup transactions for accounts 3 and 4. All we really need to do is we just need to create some. We need to create a vault, and we need to create a collection to the NFT, so that accounts 3 and 4 can own NFTs if they bid and successfully purchase one from the auction, and they also need to have a vault so that they can receive the fungible tokens that we're going to mint in our 5th transaction. I'm just going to copy pasta. This is going to be signed by account 3. We're not going to mint any tokens. We basically are going to I think that's a good enough description for now. So yeah, we're going to add an empty vault and NFT collection to account 3, and then we're going to create public references for each so that we can deposit fungible tokens and NFTs to those collections and vaults if we are lucky enough to obtain some. So we can get rid of this minter. We are going to need an empty vault. We are going to NFT collection. We don't really need vault A here. We can just create a vault. NFT collection is going to be rocks. Create empty collection, I think. Yeah, okay. So we're going to save that. So basically we're just doing what we did with the vault. Same workflow. You'll notice that a lot. Like, this stuff seems, at least to me, it seems pretty daunting at first. Like, what's the process? And if I don't see it right in front of me, I'm usually scrambling. But once you kind of do the reps a few times, it starts to sink in, and it gets at least a little bit more comfortable when you're in it to understand what's going on and what the steps are. So create an empty NFT collection. And we're going to save it, so store the collection in the account storage. So account save, just like up top. So this is where we use the @ sign because we're actually storing the resource itself. Storing the non-fungible token collection. So we're using that token standard there, and it's just, I don't know why. Like, I think it's, the reason I'm doing this is because I want kind of an abstract reference to what it is. I don't want it to be like, we're going to define a more specific name right here when we store it, right? So when we do this, we're going to store it to storage rock collection. So we're basically saving like the abstract resource
but we are like specifying which resource it belongs to. I'm not sure if that's the right way to go about it, but hey, let's try it out, and usually we will find out if we have done something silly. I'm gonna move this stuff because it's kind of sitting in an awkward place. So like we have all of our vault code sitting up there, and that's kind of a separate step, right? We're gonna do that all in one step, so might as well group all that code together so it's, you know, clear. And then similarly to what we're doing up there, we're gonna create a public, yeah, we're gonna create a public capability. Redundant naming, but I just want to be clear. So create a public collection, public capability to the NFT collection, and that will become a little bit more clear as we write this. But so we're now using a reference to, I think we're going to call rocks collection public here. So this is, I could be doing this wrong. I might have to do it this way. But I don't know. So I feel like that's probably the right way to do it. So we're gonna do it that way. So now we're gonna pop it in public rock collection, and we're going to target storage rock collection. Okay, so this is a non-fungible token. The interface is actually declared on the non-fungible token standard, not on the custom rocks contract that I created. Get rid of the minter reference because we don't need it, and we can't access it in this account. This is account 3, so can't access like the admin functions of the NFT collection. And then we don't need the execute part of this transaction because this is one of those examples where we're just setting up the account for future transactions. So down the road we will be minting our fungible tokens and depositing them in all 4 accounts, and that's what we're kind of setting up for. And then, like I said, if this account does successfully bid on a token in the auction, we want this account to be able to receive that token, so it needs to have the NFT collection. And empty. More specific, but we got a lot of code grades still, so we're good there. We want to be with account 3 on this one, so we can actually just pop this off right now. And this is going to make the what am I doing here? This is going to make the account 4 step really easy because we just need to duplicate and rename things. We're doing the exact same execution in here. So this will be a case where like we write this contract or this transaction once, and then once we have like the SDK set up, we'll just be able to use this for each account that we run the transaction on. So a little quicker for deployment, but again, while I'm learning Cadence, I'd just like to stick with Cadence, and I'll handle the SDKs on the weekend or something when I'm ready to get more adventurous. Okay, so switching account, keep account 3, good stuff. We're going to deploy or sign with account 3, and we have our vault and rock collection ready to rock for the remainder of our exercise. So just going to copy this, pass to this, and basically create a duplicate transaction for account 4. Yeah, I mean, I could just sign this with account 3, but I think it's just clearer to have separate transactions. Like, this is the exact same code. You can just sign it with more than one account. But right now, I think we can only sign one transaction with one account. Like, we can only have one signer per transaction. Pretty sure. At least with this setup. So this is just the way we're going to do it. Super redundant. I think I should just show you too. While I still have account 3 selected, we already have deployed a vault and a non-fungible token collection to this account storage. So if we try to redeploy this transaction, we're going to get an error saying, hey, we've already got things stored. Where are you trying to store things? Naughty boy. So don't do it. But it's nice, again, like it's a situation where you're not going to break anything. You're just going to be told no by the system. Love it. Okay, so now we're in account 4. We don't have anything stored in those domains, so we can just quickly execute this guy, sign it with account 4, and everybody is set up and ready to rock now. So that is great. We're going to do one more setup transaction, and this is going to mint tokens for accounts 1 to 4. Mint and deposit tokens. Yeah, interesting. I'm probably gonna run into an issue that I ran into a while ago with like just a crazy token balance. So this might be weird. Yeah, it's originally set up. Just bear with me while I root through things for a second. Yeah, okay. Yucky. Okay, so what's gonna happen is like the demo tokens are already minted with 1,000. So the original account 1 already has Okay, so I'm gonna pretend all this stuff never happened and just set things up the way I was originally going to, and then I'm gonna fix that issue after the fact. So just pretend I never sidetracked us. Okay. Just clear things out here. So what do I want? Yeah, I'm gonna have to write a bunch of nasty code in here. What am I doing? Use the tools your editor gives you, folks. Okay, so grab the public account objects for each of these accounts. We are going to want to grab the receivers references for each of these accounts. If this wasn't already such nasty repetitive code, this would be another situation where I'm doing the thing I said before and like splitting these things into multiple steps, but really we should just be iterating through like in a loop and doing things in a much more clean and organized fashion, and we're not doing that right now because, if we're being honest, I'm still learning how to do things in a clean and organized fashion, so we're going to do the best we can. So we have created references to the fungible token receivers, the demo token receivers for all 4 accounts. I've received the capabilities for all 4 accounts and created references. We have borrowed a reference to the administrator for the demo token. So this allows us to mint and create minters and mint tokens. So this is actually stored on account 1, which we're using to sign it so we can access it without having, like, you won't be able to access the administrator from anything other than account number 1. There's just no way to do it. It's closed for business. So then we're going to create a new minter. We're going to give it an allowed amount. We're actually going to bump this up to 1,000. We already have 1,000 coins from our init on the demo token, but I don't want to use those. I want to create a new minter. I want to mint the tokens specifically for this example in this transaction, just to keep everything clean and easy for me to follow. So once we've done that, we create a reference to our minter, or we create a public capability to that minter. We borrow that capability, which I don't know why we're doing that. We've saved it. Ah. Yeah, I still don't have a clue why I set it up that way. Oh well. Might just be to use it. It's weird to me though. My thoughts are I should just be able to. Oh, yeah, okay, that makes sense now. So we still need like a way to actually interact with the token minter. So we've set that up here. We've linked to the capability, and then we're using that reference to that capability to go through for each account and mint the allotted amount of tokens. Cool. We're gonna bump this up. So we're gonna do 3 and 4 are gonna also have 200 tokens each. Because I'm a nice guy, I'm just feeling generous. It's gonna leave like a surplus on account 1, but who cares? Cool, so that should work. Account 1. See a bunch more events then once we're done with this, because all the tokens will get minted and deposited. Boom shakalaka. So now we're gonna run we're gonna build a script that just checks the setup and makes sure that we have the desired amounts of all the things and all the accounts. So this is just a bit of a cheat sheet for what I'm expecting. It's quite helpful. So what we want, counts 2, 3, and 4 should have 200 coins. Count 1 should have 1,000. We minted 100. And we have 300 left over, so we should have 1,400 coins, I'm pretty sure, in account number 1. And then we should also have an array of NFT IDs from 1 to 10 in the account collection. None of the other accounts should have any NFTs. So because we're using a script, we just grab all the public account objects for the accounts that we want to interact with or that we want to query. So this won't give us access to any private fields or methods or abilities to access any resources and storage, but it will allow us to access anything publicly available so that we can read from the blockchain with a script as opposed to read and write with a transaction. Scripts also won't advance the block count. They don't actually get added into like a block, whereas a transaction will. Okay, so a bunch of duplication here again. We're going to change this to account 3. Mask the stuff. And here we're going to do the same thing. Just get our balances. Those there because we do have a bit of a cheat sheet up top. This is where we check. For now, I'm just gonna kill that because I want to check the values and see what they are, because whatever they are is technically correct, and then we can just plug those in after the fact. So nasty. Okay, so this should run and just give us a quick overview of what we actually have. So it's just going to log the balance and any, like, whatever IDs are in the NFT collection for each account. So I'm hoping my math up here is correct. Nope. Oh yeah, okay. So it only did mint the 100 tokens for the first account. Cool. Sweet. I'm gonna redeploy that and make it work properly though, because I only want that account to have 100 tokens, and that's just kind of a weird side effect that's sitting in there that I didn't intend. So what I'm gonna do here is just add some more gross checks. For account 3 and 4. And then I'll just make sure the values are correct before we go ahead and start listing tokens and having fun with things like that. So I'm gonna kill the 1,000 and we will redeploy before running this again. Should change this to 100. Good. Okay, so we're just going to repeat the old cycle. So I'm going to stop and start the emulator. That'll just clear everything out. And then I will fix that demo token initial value. Yeah, so the cool thing about these is, like, with fungible tokens, you're really just changing the amount of the total supply. There's really no, like, resource being passed back and forth. But with a non-fungible token, there is, like, the token is a resource, so it's handled completely differently. And I mean, that's where I think I've spent the most time scratching my head is trying to figure out, okay, like what the heck are these? what are these resources? What can you do with them and what can't you, right? Because it is pretty sticky. So, okay. I think that's it though. If you're just, that was the only thing we needed to change. We didn't technically mint anything, or you can create a minter. We just set the amount. That's what was messing with our values further down in the demo. Yeah. Okay. We can go back and redeploy and basically. Think we'll probably get to. I don't know. I'll check the stream time and see what we do. Should be easy enough to list our tokens. Then we can see our custom events fire and the code that we wrote today actually do something before we cut out for the day. So let's do that. Should be pretty darn easy to create the auction. Anyway. Usually when it stalls out, oh, it actually did it. I thought it was gonna fail, so I was about to stop and restart, but thank you, Amelia. So we're gonna switch to account 4. Deploy the non-fungible token standard. Switch to account 1. So we can deploy the demo token. Switch to account 2. Deploy our rocks contract for our fungible token. And switch to account 3 and deploy our Voti auction. So the fungible token that you see being deployed from this address, this is the one that I mentioned, like the onflow GitHub repo. In their README, like in their instructions, they have this, like they've mentioned that they actually have this serving from a live address on the blockchain already. So I'm not having to actually deploy this anywhere, I'm just pulling it in from the blockchain, but the non-fungible token one you still do have to deploy. That'll hopefully change soon. So, redeploy it to Japan. Make sure I've actually got it out there. Great stuff. Clean things up a little bit. So now we'll go through and set up all of our accounts from 1 to 4. So account 1, here we go. That's our Voti auction, setting up our vault reference. I don't know why I said Voti auction, it has nothing to really do with it yet. It's setting up our fungible token vault reference and creating an empty NFT collection. And also publishing a reference for that so that we're ready to receive NFTs. So with account 2, this is just going to add an empty NFT or an empty fungible token vault to account 2, and this is going to mint 10 NFTs that are deposited into the NFT collection on account 1. So we run this guy with account 2. It gives us our empty vault, and then it also loops through here and sets up, basically mints a token for every digit we've given it up here. So this will make our 10 tokens. Boom, happy things are happening. I love that. So account 3, we're just going to create an empty vault and an empty token collection. This just gets us ready to receive fungible tokens and non-fungible tokens. And account 4, exact same transaction. I honestly didn't even need to create a separate one, but we're going to do it to make things clear. And then now that we have all of our accounts set up to receive our tokens, we're just gonna run the minting script for our fungible tokens. So this is gonna mint 1,000 new fungible tokens and deposit them into the respective accounts. So that's been done. And now we can just run our check setup, and with our kind of restricted checks in place, we should see that we have the right values. Nothing angry is coming out of us. So our account 1 only has 100 tokens, 2, 3, 4 have 200 tokens each. Account 1 has NFT IDs from 1 to 10, and the remaining accounts have just empty NFT collections. Everybody's set up and ready to go. So we will do a new transaction for account 1, and this is going to allow us to just list our, like, it'll allow us to loop through our NFT collection and put our tokens into the auction queue. So then the goal would be, after we're finished with this transaction, we'll have one more script to run, and it'll just show us the auction queue that we've created via this transaction. So this is just basically being updated from the Flow Playground Marketplace tutorial. This is pretty much the same code. I'm going to have to create our owner vaults and bid vaults and all that fun stuff, and we're also going to put our minimum price, or minimum bid increment. Actually, do that on the stuff? Yeah, okay, we don't actually do that anymore. So it's cool with, like, I guess you can do it in the playground too, but now with the more recent version of the extension for VS Code and the emulator, you can redeploy. So I want to make sure we're in account 3, because that's where this contract is deployed. Now we can redeploy, and that should pull in these changes so that when I do run this create auction collection transaction, or this method, it's only looking for these 3 arguments now, because we are providing the minimum bid increment and auction length in blocks here, which I don't like anymore. I'm gonna just kill that because there's no real good reason to do that. So I would rather pass that in when we create the auction. It makes more sense that way. So we are gonna do this here now. To fix, we're gonna put it in as 5. So it's a 5 token minimum bid increment. Auction length in blocks will be urint. We're gonna go 30. So idea there is 30 seconds. Let's double check what we need for our text arguments. Owner NFT collection and bid vault. So we need to get our account borrow raw collection. So we are doing that. We just need to move this up here because we need this reference, and I just like to keep things organized. I'm not sure if the ordering counts here as far as hoisting and all that stuff goes, but we do need this reference. So owner NFT collection. And bid vault. So we're gonna create a new vault for this one. to do it here. That's something that we could definitely pass in from the actual contract side, so I'm going to change that quickly. I just don't want to have to do that here. I think. One sec. Yeah, actually no, I do. Composability. So sorry for bouncing back and forth, but requiring the bid vault at this step means that I can create any type of non-fungible token vault here. So we're going to say bid vault is where's my demo token, create new vault or empty vault, and we are going to pass that in here. Are we pulling that in? Yeah, I need to pull the account one. So what I just did there was we needed to import this contract. So we imported the demo token contract from account one. We used the demo token contract to create an empty vault. It's telling me that we're losing the resource. Oh, yeah, okay. Shoot. It's still expecting the 5 or the 3 increment or the 3 arguments because I redeployed that contract that way, I guess. Let's try it again. Let's try to redeploy. Otherwise I have to go through the whole setup one more time. Yeah. Oh shucks. Oh well. Part of the fun. Okay, so let's stop the emulator. Run it again. Yay. Create account, switch account. And deploy you. Switch account number 1. We're gonna play our demo token. Number 2, we'll do our rocks. And number 3, we will do our Voti option. Switch it back to account 1, set up our accounts. You'll notice I'm just going to use this same transaction twice because the code's the same, it's just the signer that has to change. So this is kind of redundant. I'm going to just kill it. So now all our accounts are set up to receive, so we can go ahead and run this bulk minting transaction. And we can check our setup to make sure everything's good to go. Okay, so now everything seems to be happier in here. Where are we trying to borrow?
trying to borrow. We are indeed trying to borrow a collection. This might have to do with where I stored that in that other transaction, so let me just double check. Alright, yeah, I think that's what it's telling me, because I'm trying to so I'm trying to borrow a reference to the collection, but it's actually not what's stored there. Like, I'm storing a reference to the interface, the collection public interface itself, so I think I have to redo that transaction. I think I ran into this the first time I did it too. See if I can do it this way, and I'll probably have to go through the whole steps again, but yeah. That's okay. Busy stream. Glad that link broke on me right off the start. It was pretty catastrophic to actually letting anyone join, but hopefully someone catches this and finds it useful after. Okay. Oops. Let's get our stuff going again. Okay, contracts deployed. Very unhappy. Just close them all. Sometimes the error messages hang out from before you deployed your contract, so it's always nice to close things out and reopen them after deploying, and then you can kind of see where things are actually at. So this is fine now. You also, like, if you have errors, you won't be able to click these like buttons or links to actually submit your transactions or deploy contracts. So helpful. So there we go. Account 1 is set up. Account 2 is set up. 3, 4. Now we mint and deposit. We check. Everything is good. Okay, and now we're actually able to borrow the collection that we're trying to borrow. So again, like, this is because we're signing this with account 2. With account 1, we're able to borrow the actual collection, reference to the actual collection, and deal with like the private methods and fields. So we can do things that we wouldn't be able to do from accounts 2, 3, and 4. Because if we were coming from account 2, 3, and 4, we would have to interface with the collection public interface, which is a lot more restricted and just really allows you to I think see the IDs in the collection and deposit a non-fungible token to the collection. So no withdrawing. Okay, so we've got
our receiver ref, our collection ref, our bid vault. We have everything that we need to actually create our auction collection. We're getting a loss of resource there, which is okay, because what we're actually going to do is get the tokens, IDs, collection IDs. So we're actually going to use our collection ref to call the get IDs method, which is already in place, and it returns an array. It returns the keys from the collections dictionary. So the collection contains the owned NFTs dictionary. So the keys are the actual token ID, and then the value is the token itself. So this is a handy little helper method that we've already created on our tokens contract, which allows us to get just an array of those IDs, which then we can use to process or to run some other code with after the fact. So we'll grab the token IDs from the users, the signers collection. And then we could just use a for loop. So for ID in collection IDs. Oops. This keyboard is insane. It's like the most ghetto PC keyboard I think I've ever seen in my life. It's like super clunky. I'm sure it makes a racket while I'm typing. So it'll be one of the first things I upgrade for you lovely people once the stream gains a little bit of traction, hopefully. So this for loop, just basically it's like a for each loop. So it takes every index in the collection IDs array. So this is an array of token IDs, and it loops through every index, and for every value in that index, it actually assigns it to the value of ID, and then we can use it to go like this. We just want to execute this little bit. So we have a sale. We don't have a sale anymore. We should call this an auction. And we'll update the comments in a sec. And then we want to add token to auction queue. So this is going to be, yeah, because that's going to be the token ID too, isn't it? It's going to be the token. I can't remember how I set that up now. That's why we left this nice and light. Yeah, so the full token and the start price. Good stuff. Good stuff. So I have a start price of 10 tokens. This will be the token that we're actually adding to the auction queue. You notice that I was getting a loss of resource error until we actually had everything set up properly in this method. So what was happening before is I was trying to access a method that didn't technically exist anymore. And so the code was smart enough to say, hey, like this is not going to work. So your resource is going to just end up in limbo. Please fix that. And then the other thing we can do here is we can change this to ID. So this is just going to use that ID that we have from our array of IDs. It's going to pass that through for each one, and it's going to withdraw every token in our collection and add it to the auction queue. So we won't have any more tokens remaining in our collection. They will all have been moved into the auction collection and the auction queue within that. So then once we're done adding tokens to the queue, we can just save this little bad boy in storage. So marketplace, oh yeah, this is all got to change. Auction public. Yeah, this keyboard is unreal. Like I keep tripping over myself. I'm blaming it on the keyboard. I'm like the hockey player that looks like at his stick after he misses the net, but I'm a hockey player too, so I also look at my stick after I miss the net. Cool. So we've created an auction for account 1. Listed 10 NFTs. Brew coins, my old one. Demo tokens. These are tokens. Let's use our right language here. Okay, so there's that. We're just gonna change some of the sale language here to auction. Because I like when my comments make a little bit of sense. Also just gonna clean that little fellow up. Holy shnikes. Alright, it's a long one. Yeah, cool. So we've got it all ready to go. We should just be able to pop this off right now, and we should see what we want to see. And then what we'll do is we'll create a quick script that just calls our get auction queue and returns that dictionary so that we can see that tokens have actually been added. And the other sweet thing about this is we should also see our custom events fire off when we do publish this transaction or sign this transaction. So without further ado, slate it. Look at that go. Look at those beautiful, beautiful events. So you can see multiple contracts are actually firing off events at given times too. Our rocks contract, we withdrew the token from our rock collection, so it's firing off that event. It's also giving us a start price updated and token added to auction queue event, which is a little over helpful on the start price updated side, and I might want to think about that a little bit, but that's pretty sweet. It's good, and it's also kind of confidence boosting for me because now that I know that the transaction actually executed, I'm pretty confident that we'll be able to find the values that we want in this little next piece. So we're just going to update that to use our auction. So it's just going to change to auction. That's where we've stored the reference or the capability. Sorry. Booty auction, auction public. So we're just updating that to use our proper interface from our booty auction. This will give us our public functionality, and that'll get us the, we don't need that part. That one, let's use for auction. Get auction, what do we call that? Get auction queue prices. So that'll just return it for us. We'll store it in a variable. No, we won't, we'll just log it out like wild animals we are. So we run this, we should see broken. Beautiful. Unable to borrow. Well, that should say auction, but that's not the issue. Okay, let me see what's going on here. Because we do have the auction. I think it's just probably I called it something different. NFT auction. Oh, I'm silly. I used a should use an uppercase, like should be consistent, and this I will change after the fact. What did I do now? What did I save there? Okay. Think because I linked it like this, I also need to include the resource ahead of the interface that I'm borrowing from. Let's try that one more time. Oh. I love it when things don't work. What did I do? Public. Oh, yeah, okay, I didn't actually do it. Okay, so I just messed up that last contract with a little bit of inconsistency. So I had had like a lowercase a here, an uppercase a here, an uppercase a here, and I was trying to, like, these are case sensitive domains, so when you do add these, make sure that you're using the right casing. I'm just gonna clean that up because it's heinous. Like, I don't want it to be gross like that. I want them to be uppercase. It's kind of the convention that I like to use. So bear with me while we do one more start to finish setup. And no, it's not really that painful, to be honest, because like I said, like after you get working with the SDK a little bit, you can automate a lot of this setup stuff. I'm just kind of choosing to do it this way because it's easier to work with the contracts and not have to worry about, you know, what's breaking. Is it my contract code? Why? Just love it when it creates those accounts the first time. Yeah, so like by the end of the week, I'll probably have a Go script that automates most of this stuff. That just seems like the right way to go. I don't really feel the need to put myself through this every time I need to set something up from scratch. But it has been helpful actually running through this process numerous times, learning this stuff, just because, you know, it gives you a good feel for what's actually going on and like the order that you need to process things in. Okay, so I just like to close those out. Like, I like to close everything out after I've deployed, and that way when I open it up again, you don't get all the errors. Or at least you shouldn't. If you do see the errors, then that usually means that you should check things out and make sure your code's right. So set up account 1. And 4 both use the same code. Beauty, everything's going. Check our setup, just... Oh, yikers, what happened there? Oh yeah, I didn't actually mint, so that's why we do that. So I set up our accounts, but I didn't actually send any tokens to them. So our check just freaked out on us and said, hey, do it properly. So now we've done it properly. We're good. We can get through to the next step. Okay, so now that we have the right tokens in the right places, we're going to do one more quick check and make sure that we're naming all of this consistently. So storage, NFT auction, casing is important. Matching here. Good. Still using account 1. Go ahead. We've created our auction collection. So now we have tokens listed for auction, and we should be able to now see that collection and those prices that they started with when we execute this. And we did it. So there we go. That's our auction queue. That's our token ID along with their start price. And from there, we'll be able to start getting into some fun stuff where we actually get to start the auction, manage it, run some bids, and then get into like the governance or the voting aspect of this. It's not really governance, it's more of just a frill where once you enter a bid on one of the tokens that are in the auction, you'll be able to receive a ballot, and then you'll be able to submit a bid for which token you think should come up next. So I'm hoping that it's just a fun way to move things along in the auction. It's really just experimental, but it's just a way to kind of wrap my head around some of the nuances of Cadence. So hopefully, I know the stream was pretty boring to start off with. This is actually my first ever stream, so I just wanted to kind of get out of my comfort zone for a few hours, put something up on screen, and hope I can kind of inspire one or two of you out there to jump into Cadence and Flow and start learning some smart contract development. It's really a lot of fun. So if you did hang out for the entire thing or just watch this video after the fact, thanks for coming by, and hopefully you got something out of this. We'll probably do something, we'll probably continue on with this another day or two this week and get this contract, or at least this little experiment, ready to work with the SDK, and kind of get something set up for, like, I want to work with the JavaScript side of things a little bit and have something a little bit more fun to work with on the front end as well. I was super inspired by Daniel's demo today. That was, I'm pretty sure that was kind of a special one for the open world builders class, but it was super inspiring. It was like I almost didn't do this today because I wanted to go set up the Go SDK like test suite for myself and just kind of have a basic set of tooling there to speed this whole process up. So the goal for the rest of the week is I want to get this auction system working, and then I want to be able to bring it into a front end, kind of, you know, test it out in a little bit more of a fun visual way, and use it as kind of a test suite to set up some basic tooling for other development projects, because this is where I intend to spend my time from now on. So thanks again for hanging out. I'll see you again probably thinking Thursday. We'll see. I'll tweet out on Twitter, and I'll try to make sure that the link actually works this time. Oh, Miss Chris. Sorry, I didn't pay attention to chat. I've been hanging out alone the whole time. So, there. This is Cadence. So this is a new language that's been built for Flow, the Flow blockchain, and that's if you're following the blockchain space, the CryptoKitties team, Dapper Labs, they're coming out with their own solution for like more of a faster-paced game development system. So I really like it. Like, I find it's mind-bending at first, but it gets really comfortable really quick. I find reading Cadence becomes pretty easy fairly early on. Like, within about 2 weeks, I was pretty comfortable poking around within the files themselves. Writing is obviously still coming along, so but you know, all in all, it's been a great language to learn. It's specific just to the Flow blockchain right now. It has some, like, it was built using Go, and it's definitely takes some inspiration from Move, which is what the Libra team is using, and that's where kind of the resource-oriented programming concept comes from, and things like those arrow move indicators and stuff like that. So I'm not sure if you're still here, but sorry for not answering your question right away. I was lonely. I was getting used to it, so I just kind of got into the groove and blabbed at the screen for a while.